Have you ever heard the most classic joke in software engineering? 9 women cannot make a baby in 1 month? This statement is no joke. It is the most famous metaphor from the Mythical Man-Month, written by Frederick Brooks in 1975. In plain English, it means adding human resources to a late software project only makes it later. Brooks wrote an entire book to tell us men and month are not interchangeable units. One engineer working for 12 months does not equal 12 engineers working for 1 month. Because you have to spend time communicating, training newcomers, and coordinating, and for every person added, the communication channels increase at a quadratic rate. Well, this theory has held up for 50 years, but here is the core question: what if half of those actors are AI? Today, our topic is simple yet bold. Does Brooks' law still hold true in 2026 when AI agents are fully penetrating software development? Which parts are disrupted? Which parts have actually become more real than they were 50 years ago? Ready? Let's begin. Let us spend 3 minutes to re-understand what Brooks actually said, because many people only remember that quote, 9 women cannot make a baby in 1 month, but the depth of this book goes far beyond that golden quote. Brooks was the project manager of the IBM System 360 operating system in 1975. What was the System 360? It was humanity's first attempt to build a universal operating system that spanned across all hardware configurations, a scale that no one had ever attempted at the time. And it was delayed, of course it was delayed. What software project doesn't get delayed? When Brooks examined why it was delayed, he found a highly counterintuitive phenomenon. Adding manpower to a late software project makes it later. Why? He gave 3 reasons. First, training cost. Experienced developers must spend time training newcomers. If an experienced developer's productivity is 100%, it drops to 60% during training, and the newcomer starts at -50% because they ask questions and make mistakes. Together, their net productivity is lower than that of the single original developer. Second, communication overhead. A team of 5 has 10 communication paths. A team of 10 has 45. A team of 50 has, well, calculate it yourself, 1,225. Brooks' formula is n times n-1 divided by 2. This number grows quadratically. Third, and what I believe is the deepest insight, some tasks are inherently sequential and cannot be split. You cannot divide the design of a system architecture among 5 people at the same time. Just like you cannot have 9 women carry a single baby at the same time, it's a biological constraint, not a management problem. Brooks also proposed other classic concepts. No silver bullet. No single technology can increase software productivity tenfold. Second, system effect. An engineer's second design is often over-engineered, bloating with all the features they didn't dare to put in the first version. And conceptual integrity. It is better to have fewer features but consistent design, rather than more features but chaotic structure. This book was published in 1975, 51 years ago. For 50 years, people have been asking, is the silver bullet here yet? Object-oriented programming? No. Design patterns? No. DevOps? Getting close but no. Microservices? Well, honestly, they created more problems than they solved. Then in 2022, ChatGPT arrived. In 2024, Cursor, Copilot, and Claude Code arrived. In 2026, we have AI agents that can autonomously write code, perform code reviews, run tests, and even manage subtasks. So the question today becomes, does Brooks' The Mythical Man-Month still apply in the AI era? I believe the answer is partly disrupted, partly reinforced, and partly something we have misunderstood for 50 years. Let's break it down one by one. The first disruption, the first crack in Brooks' law. Brooks said communication cost is n squared, right? But that is the communication cost between humans. Now imagine a scenario. You are a tech lead, and you have 5 human engineers and 5 AI agents under you. You communicate with human engineers. You have to check their availability, schedule meetings, handle context switching, and consider their emotions. Yes, that matters. Engineers are human. You communicate with an AI agent. You type, it responds in seconds. No waiting, no warming up. No, I just finished a meeting, give me 5 minutes. And after you ask it something, you don't need a follow-up meeting to confirm it understood, because it either gets it right or you correct it on the spot. What does this change? The core assumption of Brooks' law, that communication channels grow quadratically with every person added, is broken because the marginal communication cost of an AI agent is close to zero. And wait, here comes a more radical version. What if AI agents can communicate with each other via the Model Context Protocol or agent-to-agent interfaces? Their communication doesn't require eating or sleeping, and they won't leave you on read on Slack. Their communication cost is ON, not ON squared. You might say, wait, isn't this just like microservices? Yes, it is very similar. The difference is that microservices are static while agents are dynamic. A microservice won't automatically adjust its behavior because you change the requirement. An agent will. So the first conclusion? AI agents break the quadratic communication curse. But the premise is your team must know how to communicate with AI. The second disruption, the silver bullet paradox. Brooks said there is none, but AI might be the first. Brooks said there is no silver bullet. His reasoning was that the essential difficulty of software development is conceptual, understanding the problem, designing abstractions, and ensuring consistency. These cannot be solved by tools. He was half right. Brooks divided software complexity into two types: essential complexity, the complexity inherent in the problem itself. For example, if you are building a rocket navigation system, the math is just hard. Accidental complexity, the complexity added by tools or platforms. For example, spending 3 days setting up a CI/CD pipeline, writing boilerplate code, or figuring out why a package hates you. AI's impact on accidental complexity is devastating, not an improvement, but destruction. Let me share some real data. Research from Anthropic shows that developers using Claude Code write boilerplate code 5 to 10 times faster. They write tests 3 to 5 times faster. And their speed in understanding legacy code, this is the most shocking part, increases by more than 20 times because the AI can map out core graphs before they even ask. So is AI a silver bullet? Strictly speaking, no. Because the silver bullet Brooks spoke of meant a tenfold increase in overall productivity, not just parts. But AI is more like an armor-piercing shell. It doesn't speed up everything tenfold, but in those most tedious, time-consuming, and least creative parts, it absolutely achieves a tenfold gain. And more importantly, the armor-piercing shell pierces through the armor of accidental complexity, allowing you to focus your energy on the truly difficult essential problems. This is actually better than a silver bullet, because a silver bullet makes you think the problem is solved. An armor-piercing shell tells you the obstacles are gone, but the hard problem is still there. You have to face it yourself. The third disruption, the redefinition of Man-Month divisibility. Let me explain this with a real case study. In 2025, a company named Cognition Labs ran an experiment. They had a senior engineer lead 5 AI agents to build a medium-sized SaaS product, including back-end APIs, front-end pages, database schemas, CI/CD, and monitoring dashboards. Traditionally, this would take a team of 5 humans about 3 months. The result? The engineer plus 5 agents completed it in 6 weeks. The productivity multiplier wasn't 5 or 6 times, it was close to 10 times. Why? Because tasks that were previously indivisible, writing tests, writing docs, fixing lint errors, adjusting CSS, could only be done one by humans because everyone's context was different. But now, AI agents can process these microtasks in parallel, and their contexts don't get mixed up. So the indivisibility in the Mythical Man-Month has been redefined. Brooks was right. You cannot divide a complex architecture design among 10 people at the same time. But once the architecture is established, most engineering implementation tasks can now be partitioned. And the partitioning cost is far lower than before. What is this like? It's like putting a massive iceberg into a microwave. The surface ice melts first, turning into flowing water. The core is still hard, but the surface area is much larger. But here is a trap, and it's extremely important. When AI allows you to do more things in parallel, you might also accelerate 10 times in the wrong direction. If you design a terrible architecture, the AI will implement this terrible architecture with supreme efficiency. What used to take you 3 months to realize was wrong, the AI will now build completely in 1 week. That is not acceleration, it is accelerated suicide. The fourth disruption, the second system effect, AI makes it even more dangerous. Brooks said the second system is often over-engineered because developers pack in everything they didn't dare to do in the first version. In the AI era, this effect is magnified. Why? Because previously, the price of over-engineering was the execution cost. You had to write all that code yourself, you would get tired, and you would naturally simplify. I doesn't get tired. If you tell an AI, help me add an event-driven messaging layer, even though I only need a simple REST API, the AI will say, sure, and generate a complete Kafka configuration plus 6 microservices in 5 minutes. Human developer laziness was historically a natural design shield. Because they were too lazy to write it, they didn't over-engineer it. AI has no laziness. This is what I believe is the most dangerous aspect of software development in the AI era. When you increase productivity tenfold, but don't increase judgment, you are just producing trash 10 times faster. So the second system effect hasn't disappeared in the AI era, it has become a double-edged sword. One edge helps you build good products faster, the other edge helps you ruin bad products faster. What is the solution? I believe it is using AI to fight AI. Let an AI agent act as an architectural gatekeeper. If there is an unnecessary dependency in your PR, it flags it. If your design deviates from established principles, it blocks it. If your scope creep goes out of bounds, it calls you out. Use AI's rationality to fight human I want it all impulses. The fifth disruption, the tar pit. You sink faster, but you also climb out faster. Brooks said large projects are like a tar pit. The more you struggle, the deeper you sink. AI's impact on this pit is highly contradictory. On one hand, AI lets you dig the pit faster. You can write code in a week that used to take a month to accumulate. But if that code is spaghetti code, you'll be knee-deep in the tar within 7 days. On the other hand, AI also makes climbing out faster. If you decide to refactor, AI can help you understand all project dependencies, auto-generate migration scripts, and write tests to ensure behavior remains unchanged. A refactoring that used to take 3 months might now take 3 weeks. So the question becomes, in the AI era, do you sink faster or climb out faster? The answer, it depends on when you decide to climb. If you keep ignoring technical debt, AI will help you accumulate debt faster and larger. But if you review regularly, doing an architectural review every sprint, AI can help you pay off debt much faster than before. That is what I mean. AI is both the accelerator and the brake. The key is knowing when to press which. The sixth disruption, which I believe is the deepest one. This is the last point, and the easiest to overlook. The traditional productivity formula was output equals headcount times time times efficiency. Traditional management manipulated these three variables, adding people, compressing timelines, and forcing efficiency. In the AI era, the formula becomes output equals headcount times time times efficiency multiplied by 1 plus the cognitive leverage multiplier. The key is this cognitive leverage multiplier. It is not a constant. It depends on your ability to ask questions. If a developer's prompt is help me write a login function, their leverage multiplier might only be 1.5. But if their prompt is I am building a multi-tenant SaaS platform where user roles are admin, editor, and viewer, we need to support SSO and MFA. Please design an authentication architecture that balances security, scalability, and development speed. Their leverage multiplier could be 10 times. What does this mean? The core argument in the Mythical Man-Month that human judgment is irreplaceable is reinforced, not weakened. Brooks said the essential difficulty of software development is conceptual. It's figuring out what you actually want to build. AI accelerates the how to build part, but what to build and why build it, these remain human jobs. And not only that, because AI makes the how so fast and cheap, it makes the decision of what to build even more critical. Because you no longer have the excuse of coding is slow, let me think it through first. Now coding is fast, so have you thought it through? In the new era, a team's productivity is no longer determined by headcount times months, but by 3 things. I call this the cognitive anchor model. The first anchor, decision quality. Is your architectural decision correct? Is your feature prioritization reasonable? Are you doing the right things? These cannot be replaced by AI. AI can help you analyze data and provide pros and cons, but the final decision, who is responsible? Humans. Decision quality determines whether you are accelerating success or accelerating failure. The second anchor, prompt engineering capability. By prompting here, I don't mean prompt engineering in the sense of writing prompts, but in a broader sense, can you break down a vague requirement into clear instructions that AI can execute? Can you effectively transfer your domain knowledge to the AI? This is a new core competency. Those who cannot communicate with AI will not see much higher productivity in the AI era. Those who can communicate with AI can achieve 5 to 10 times productivity. The third anchor, feedback loop speed. Can you quickly judge whether what the AI gave you is right or wrong? Can you quickly correct the direction? This requires deep domain expertise. A junior engineer using AI to write code cannot spot whether the AI's code has potential race conditions or security vulnerabilities. A senior engineer looks at it and knows instantly, saying change this here, that part is fine. So the distribution of this new capability is, the more senior you are, the higher the AI leverage multiplier. This is the opposite of what many people think. Many think AI will replace juniors, but in reality, AI makes seniors even more formidable. If you are a tech lead or manager, you should ask yourself 3 questions. First, does my team know how to collaborate with AI? Not just using Copilot to write code, but knowing when to ask AI and when to do it themselves. Second, do I use AI for architectural governance? Or am I letting AI help everyone accelerate chaos? Third, what is my team's cognitive leverage multiplier? If everyone's leverage is only 1, the problem isn't AI, it's that they don't know how to use AI. So, does Brooks' The Mythical Man-Month still hold true in the AI era? My answer is, Brooks was half right, half wrong, and partly something we've misunderstood for 50 years. The part he got right, human judgment, conceptual integrity, and decision quality, these have actually become more important in the AI era. Not because AI replaces them, but because AI magnifies their impact. The part he got wrong, the quadratic communication curse, the indivisibility of man-months, and the absence of a silver bullet, these have been fundamentally changed by AI, not a tweak, but a paradigm shift. And the part we misunderstood, we always thought writing code was the hardest part of software development. But Brooks told us long ago that the hardest part is deciding what code to write. AI just makes this fact completely naked, because now writing code takes 5 minutes, but the consequences of deciding what to write can affect maintenance costs for the next 5 years. So my advice to all engineers and managers is, don't ask, will AI replace me? Ask, what is my cognitive leverage multiplier? If you only know how to write code, AI will replace you. But if you can judge what to do, what not to do, and when to stop, AI is your ultimate tool. Finally, let's end with a quote from Brooks in his 1995 20-year anniversary preface. There is no silver bullet, but that does not mean we should not strive. Now we have AI. Do you know which direction to strive? I'm Dennis. See you next time.